Hi guys, good evening. So I'm Isham. I'm from Enterprise Architecture Group, and for the past few weeks, we've been looking into best practices for mobile development, and we came across this MVVM, so which is an architectural pattern. So today I'm gonna uh, share everything we learned, and then hopefully next time you start a mobile application project, you can also consider this for the adaptation. So to start with, today's agenda will I'll walk you through a traditional UI development, and then we'll discuss about what are the drawbacks on doing in a simpler way, and then we'll go in deep of MVVM, and we'll compare MVVM with other existing patterns, similar patterns. We'll finish it up with pros and cons. Okay, so when it comes to traditional UI, it is simple. So let's say your application is simple. You just you have only a few buttons and you have only a few text field. You can put every logic in the view layer. So basically, what you do is for every user action, you basically have an action listener, and then you just call an API, fetch the data, and then you show it on the front end. So it is simple enough if your application is simple. But if you have more dynamical behavior on your application and you have many moving parts, you have complex business logics, well, this pattern might not be a suitable one for you, because now if we try to interact view directly with the model, there will be coupling between view and the model, right? And then UI has to worry about the logics of fetching the data and then interact with the model. So the UI gets more complex, and obviously we won't have the separation of concerns at all. And also it is hard to test. So when it comes to testing at the view level, it is really hard, and you know this. So to overcome this issue, we need to decouple these things, and there are a few patterns like that. So one of such is MVC. So most of you might know about MVC, might have worked on MVC, and one another alternative of MVC is MVVM. So today we're going to talk about how MVVM overcome these issues. So basically, MVVM stands for Model View ViewModel. So it was introduced by Microsoft, and it is an architectural pattern for your presentation layer. So we are not going to talk about the entire multi-tier architecture of a mobile application. So today I'm mainly focusing on, or this pattern mainly focus on interaction between the model and the view. So basically, how we decouple is we introduce a new component between model and view, which is ViewModel. So to go deep into each component, so we'll start with the model. So usually this model is your application data and business logic. So this is your typical model on any applications, right? So it cannot see the view or view model. It wouldn't know that there is a view or view model acting on top of it. So it's just a very pure business logics, and it should not contain any use case or task specific logics. So for example, like let's say login flow. So anything happens in login flow or navigation, those type of application specific tasks, specific logics should not be in the model layer. So this will be purely business logics. For example, like user. And also in this pattern, the model can also provide validation and error handling, but these validations are not like user input validation. Rather, this is basically the validation error handling, which contains within the business logic itself. So whether the item exists on our inventory, or whether this is a valid SUPC number, something like that. Those things can be in this model layer. So when it comes to ViewModel, and even though it says ViewModel, we don't have any visual classes in this ViewModel. So it purely non-visual classes. When I say visual classes, it's basically components like text fields or the buttons, so those type of reference or any reference to the view should not be there in the view model. So to be precise, it wouldn't even know there is a view layer acting on top of this at all. So this purely, so view model is purely for coordinating the behavior between our services and the model. So this is where we call our services. This is where we use our business models, and this can also provide us data validation and error handling. Basically, this is where we put all our like input validations and application specific error handling comes into this level. And as I earlier mentioned, this doesn't have any reference to the view. So the way it let the other view layers knows that there are changes been happening is basically using this notification mechanism. So when we look into the view layer, so view layer is basically your typical view layer, your XML definitions of these UI components, as well as the actual direct UI logic class which attached to that XML page is basically the view layer here. And this can see the view model. So this has access to all the other components. So this is basically where we actually bind the view model with the view. So when we see in detail how these things come together, so basically this modular architecture allows us to easily swap the components. So I will show in the code example how easy it is to even swap a view or a model. Even swapping a view model is really easy with minimal code changes. And also, like obviously, like MVC patterns, this also allow us to change the internal implementation without affecting any view or model layers. And this is very decoupled, but the most important thing is this actually allows us to do unit testing of view. So even though this doesn't have any reference to the view layer, this actually allows us to reduce the front-end testing and takes some of those testing into a unit test. So we can unit test the view model, and we can actually skip a couple of testing at the view layer. So we'll see in depth on how these components interact with each other. So basically, interaction between view model and model is a typical way of interaction. So basically, view model has reference to the model and services, so it can manipulate the models and use that model to execute the business logics. The difference is the interaction between view model and view layer. So there are three types of interactions when it comes to view model and view layers. First one is notification, as I already explained. If any state change happens at the view model layer, so view model layer lets other view layers know that these are the changes happens to my state by notification. So only the notification we will let them know, and every time a view layer receives this notification, it will retrieve the data which got changed. In contrast, let's say if you take the MVC pattern, there can be reference to the view layer at the controller, or like the view layer will wait on the controller to get back its data. So there are no such interaction here. So basically, we will let this view layer know, and then when we want to retrieve the data, we use this thing called data binding. So most of you might know about this, which is like two-way binding. So a two-way binding allows view layer to actually pull any data from the view model, and also it allows the view layer to actually push any data to the view model. So anything happens at the view will be reflected at the view model, and vice versa. And the third one is commands. So commands is the way we actually handle the user events. So like event handling and happens through commands. So let's say if you take MVC as an example, usually what we do is we have an action listener at the UI layer, and we basically call the controller from that action listener. So that's how we basically build the connectivity between view and the controller. But at the MVVM pattern, we have no such like pass through. Rather, we directly call a ViewModel's method from the view layer using these I command interfaces. So I will show all these interaction in real coding examples so that you understand this better. So I'm just comparing this MVVM with MVC. So what you are seeing in the picture is a typical MVC pattern. So where we have these kind of like cyclic dependencies, where any user interaction or the action event handling actually happens through these calling functions within this view layer. So in the view layer, there will be action listener, and that function actually calls another function inside the controller. That's how this controller and view connects. And the controller and model interaction is similar to what we have in MVVM. So the view model actually interact with the model in a similar way. But when it comes to showing the results to the view, there can be like coupling between models in a cyclic way. So that is the difference between MVC and MVVM. We'll talk about advantages. So as we already know, it separates these components fairly better, and also this is mainly test driven. So as you already saw that this view model can be easily unit tested, and that actually allows us to technically test the front end as well. So we can have more code reusability, so we can share a view model between many views and without any code modification whatsoever. And then this also allows developers or designers to design this front-end code without having to worry about this action listener or without having to worry about these bindings at all. They can simply in parallel they can design their views, as well as the others developers can develop the actual application behavior at the view model, and to connect them they just have to align the variable names. That's all. And also, as I explained, it's easy to switch UI components. But we also have some drawbacks here. So first one is hard to debug. So basically it's most of these front ends things we usually have is taken now into ViewModel, and we don't have a direct reference to any of these front end elements, right? So let's say if a front end element not behaving how we expected, we cannot just find that front end elements reference and then see what's going wrong, right? So there are no front end element reference in the code. We just have to debug a bit more carefully to identify what's going wrong. And the second one is it's too complex, right? So let's say if you are developing a simple application, you are not worried that much about unit testing your view layer. Well, this might not be a suitable framework for you, but this actually allows you to do things way better. And if like a proper pattern or proper decoupling and proper testing is one of your concern, which is when it comes to developing enterprise application, then MVVM is one of the best frame or architecture pattern you can adapt to. And one more thing which is essential here is the two-way binding, right? So with a two-way binding, we anyway have to have reference to these front-end component at the code level, and we have to manipulate them at the code level. So without this support for this two-way binding, this MVVM pattern cannot be realized, or cannot be realized as easy as how I showed in this Xamarin example. But luckily, even if you are developing Android Java, so there are ways to do two-way bindings. There are libraries. So this is one such way of doing two-way binding on Android. So let's say this is your visual components. What you have to do is similar to what I showed in this Xamarin example, we just have to bind these things like this, bind this each variable like this, and then we just have to define propagators and setters at the ViewModel layer so that it actually allows us to do these two-way binding. So all these main mobile development framework actually supports two-way binding in MVVM. So I hope you get something out of this session, which is an interesting architectural pattern. And next time, if you are trying to start on a mobile development, without directly jumping to an MVC pattern, you can actually take a moment and think whether we can use MVVM. So I think that's it for the session, and I don't think so we can have a Q&A. So we'll wind this up. Thanks for listening.